the distance in meters, it's a distance function, okay, is found by this formula where t is time and s is the distance, and it's in meters. So make sure time is greater than 0 and time is in seconds. And so this is a position function, and we're asked about acceleration. So s of t is position. The derivative of that would be change in position over change in time, and that's velocity. If position is in meters, velocity would be meters per second. Now the second derivative is the change in velocity over change in time, and that is acceleration. And the units for that would be meters per second. Per second, we call it meters per second squared. So, if your position function is negative 3t fourth plus 18t squared, then your derivative is negative 12t cubed plus 36t. And your second derivative would be to take the negative 12, bring down the 3 and take t squared, and then plus the 36. So that's going to be negative 36t squared plus 36. That is your second derivative. That is your acceleration. Find when, that's a time, the particle has acceleration equal to 11 meters per second. And so we have then to set acceleration equal to 11. Negative 36t squared plus 36 equals to 11. Our job is to find the t where this happens at. And so we'll first notice that there is no t term, and that makes things easier to solve. We'll isolate this t squared term, and we'll end up taking the square root to solve for t. So let's see here. What's the best way to do this? I think actually we'll end up taking this 36t squared over and then moving the 11 over. So 36 take away 11 is 36t squared. Are you sure this is right? Negative 12 plus the 30. Yeah. Okay, well, it's just not going to come out to be something that's okay. But watch though. When you take 11 away from 36, you get a 25. Okay. So when I first saw this in my head, I was thinking, wow, this isn't going to be an integer, but that's okay though, because when you divide by 36, at least what you'll have is a perfect square. 25 over 36 is equal to t squared. So when we take the square root, we're going to have t to be, well, technically it's going to be at first plus or minus 5/6, but t must be positive, so t is going to be equal to 5/6 of a second. Okay, that's the time when the acceleration is equal to 11 meters per second squared. Number 12. Also a distance function, a position function. So we have the s of t is equal to 2 times the sine of 2t. The derivative is velocity. And that's going to be, keep this 2. The derivative of sine is cosine. Leave the inside alone, then multiply by the derivative of the inside. That's the chain rule. Multiply by 2t's derivative, who is 2. Now we have a 4 times the cosine of 2t, and therefore we want to put that together first before going to the next level and finding the acceleration, which would be the second derivative. So we keep the 4. Cosine's derivative is negative sine, leave the inside alone. Chain rule says multiply by the derivative of 2t, which is again a 2. So this time we have a 2, a 4, and then a negative 1. So altogether, negative 8 times the sine of 2t. And this question is asking us for the velocity and the acceleration when time is pi over 4 seconds. So the second derivative at pi over 4 and the first derivative at pi over 4 is what we're asked to find. Okay, great. Now, plug in pi over 4 to the first derivative. 4 times the cosine of double pi over 4. Look in the parentheses. Use this 2 to cancel this 4 and turn it into a 2. And we're looking at 4 times the cosine of pi over 2. On your unit circle, you'll see that the x-coordinate at pi over 2 is a 0. So cosine of pi over 2 is a 0. And so this answer is 0. Then when it comes to the acceleration at pi over 2, the acceleration at pi over 2 is negative 8 times the sine of double pi over, oh sorry, the acceleration at pi over 4. I said pi over 2, but I wrote pi, I don't know, sorry about that. It said pi over 4. So here we go. And we still plug in the pi over 4, it still cancels. Now we're talking about the sine of pi over 2, which is 1. And so that's a negative 8 times a 1, or a negative 8. And so we have the answer to that question. Units, this would be in, we assume, oh, let's say feet and seconds, right? So this is feet per second. That's what, if the position is in feet, then the velocity is in feet per second, and the acceleration is in feet per second squared. Okay, it's a negative acceleration. It's decelerating.